Hello there, great person. Welcome and welcome back, perhaps, to this channel and this reaction series. So, you ready to do some science? Today we're gonna take a look at the stellar engine, and I will give you my little comments, little insights, some perhaps additional informations I have. Yeah, as I said last time, I am a scientist, I'm a quantum physicist, but I'm not an astronomer, or not an astrophysicist. I know a bit about that, all self-taught, so if I do some hiccups, I'm sorry, correct me in the comments, and let's enjoy this together. Let's see what a stellar engine is, because I don't know. So, yeah, was recommended by several of you lovely people. Thank you for that, and I will gladly watch it. Just get into this. Let's see what the stellar engine has got for us today. And we apparently want to escape supernova. Sorry that it's in German. My YouTube sometimes translates stuff randomly.
Nothing in the universe is static. In the Milky Way, billions of stars orbit the galactic center.
I'm sorry to interrupt it here already. Yeah, that's something many people don't realize. Everything moves. I mean, you always have your point of reference, so if you look up, you always feel like you are not moving, and stars seem static, and yeah, but no, everything moves, everything moves, everything moves through space, and yeah, you might argue not from every point of view. Sometimes you yourself don't move, but yeah, generally everything moves. The universe is incredibly dynamic. It's not that static thing that you might perhaps think of, not like there's a star and it's there, it's always there. No, stars move, black holes move, comets obviously move, suns move, which are stars, I'm sorry. And yeah, so, yeah, let's see. I'm sorry, let's go.
Like our sun, are pretty consistent, keeping a distance of around 30,000 light-years from the galactic center, completing an orbit every 230 million years.
And that's quite a lot.
This dance is not an orderly ballet, more like a skating rink filled with drunk toddlers. This chaos makes the galaxy dangerous.
There was a black hole.
Our neighborhood is constantly changing, with stars moving hundreds of kilometers every second.
From our point of view,
the vast distances between objects protect us from the dangers out there. But we might get unlucky in the future.
Yeah. Okay, that's very good. Yeah. That's something you might fear that. You might fear that something hits us, something does terrible stuff to us, and yeah, I mean, he said it here quite correctly, as I think. Everything is not as predictable as you might think. There are stars going around in stupid patterns. There are black holes that might be rogue. There are, I don't know, planets that have been shot out of their solar system and fly around, might hit us. Gamma rays, okay, they're not really moving objects, but moving electromagnetic fields and little particles. So yeah, take that as you will. But yeah, it's quite dangerous theoretically. But then again, look at how small the Earth is. Look at how much volume around it is, and yeah. So, what is the English word for it? I will try to translate it from the English version I know. So, if there's someone who knows the English version, you can correct me in the comments, because I will butcher this. It's the interaction. What would you call it? Interaction. I only know the German word. Interaction average? No. I will just explain it. So if you have a sheet of paper and there's a dot on it, and you shoot 1,000 bullets on the dot, it's not very likely that you hit the dot. So the probability of interaction is very low, and it's the same with Earth. So if Earth is an atom and you shoot at I don't know, the atom is on a football field and you shoot at it, you probably won't hit Earth. So that's like this. It's even more improbable. But then again, the universe is big and there are many things in it, so it becomes probable again a bit more. So, you know, it's like a kind of, you know, you have to take both of those things into account. And yeah, let's see what will kill us now in this video.
At some point, we could encounter a star going supernova.
Oh,
or a
yeah.
massive object passing by and showering Earth with asteroids.
Or itself.
If something like this were to happen, we would likely know thousands, if not millions of years in advance.
Except for if it's a rogue black hole. Which was something I think we had in the last video. So if it's a black hole and it does not have an accretion disk, it just shoots through space, you might detect it really late, because you have to detect it by the interactions around it, and if there's no objects that you can really detect and see around it, you might not see it. That's quite scary.
But we still couldn't do much about it.
That's true.
Unless we move our whole solar system out of the way.
Okay. I'm still with you. Oh, what was that? I'm sorry, this is something I want to say. An atom doesn't look like that. Not like the ball with the swirly things around. It doesn't even make sense to try to visualize it in our space. So that's the quantum physicist in me. I get triggered by that. But it doesn't matter. It's a good picture.
To move the
for
solar
things.
system, we
You can
need
use
a
it for
stellar
things, that
engine,
model.
a megastructure used to steer a star through the galaxy. It's the kind of thing that might be built by an advanced civilization with Dyson sphere level technology that's thinking about their future millions of years ahead of time.
Okay, so I don't know if you know this thing. The Dyson sphere is a theoretical construct used by a very advanced civilization that has a lot of resources. So in theory, you just build a giant sphere around a star to catch all the radiation that's coming from the star. So you, so to speak, control all the energy in the solar system from the star. And there's this... Oh my god, I'm so sorry, I forgot the name. The Chandrasekhar scale? I don't know how it's called. It's the scale where you can... you measure civilizations by how much energy they can use, and by that you theorize what technologies they might use. So we are currently a type 0.8 civilization because we can use so and so much of the Earth. Then the next level would be the Sun. Next level would be several solar systems. Next level would be galaxy, then universe and multiverse, and you go to interdimensional travel and stuff you could theoretically do. It's just a theory, just a hypothesis, but it was a suggested scale to measure civilization levels. And this one here, he talks about I think it's a type 2 civilization, and they can theoretically build this Dyson sphere thing, which is absolutely amazing. It has been used in many sci-fi novels, and I suspect it will be used in the Foundation series that is gonna drop soon, I think in a week, and I will react to that. But yeah, so they have a Dyson sphere around a black hole, which is even more scary, so yeah. Let's see how they move the solar system.
But
Let's
how
see.
do we possibly move the hundreds of thousands of objects in the solar system?
Yes, how do we do
The
that?
good news is we can ignore all of that. We only need to move the sun. All the other stuff is glued to it by gravity and will follow it wherever it decides to go. There are
That might be possible. I'm not sure about that, but this is not my expert opinion. Because it would introduce a disturbance into the system, you know, a little disturbance. I don't know if chaos theory would take over, but I think it's right. I think that's probably correct. It's very, if you think about it, you know, it goes into a direction. Wouldn't it smash into a planet because the gravity doesn't push? So I think it depends on how quick the sun will move. I would like to see some calculations for that. You've told me they wrote a paper on this engine. I will look at that. Just for myself, I won't do it on this channel. I think nobody would probably be interested anyway, and I don't know if I would understand everything, but that's something I would be interested in. Because, see, if let's say Jupiter just moves in front of the sun and it starts to go by, I don't know how many kilometers per hour. Let's say, let's be really stupid. Let's say 10% speed of light, it would just smash Jupiter. I'm not sure. You probably would have to control the acceleration. If you accelerate slowly, it might work, because then the planets have time to adjust to the new way of movement. I mean, we are currently moving through space with the solar system and the planets as well. I don't know if you've seen this animation where it's like a spiral, you know, the solar system. So if this is the plane you see here, so let me do it. So this is the plane, the sun is on, let's say the sun is here, and it moves like this, like spiral. It looks really cool. So yeah. I don't, but the acceleration thing is the thing. It's not the velocity, it's the acceleration that I think it probably would have to be very, very slow steps to accelerate. I'm not sure, I might be wrong here, but that's how I would, with my limited knowledge on this, think about this. But
there are lots of ideas about what a stellar engine might look like and how it would work. We've picked two grounded in our current understanding of physics that could be built in theory. The simplest kind of stellar engine is the Shkadov thruster, a giant mirror. It works on the same principle as a rocket. Like rocket fuel, the photons released as solar radiation carry momentum. Not a lot, but a bit. For example, if an astronaut turned on a flashlight in space, it would push them backwards very, very slowly. A stellar engine will work a little better.
yes, that's so cool, isn't it? I love that. It's so cool. That's and that's so interesting, because a photon does not have mass, but it has, so to speak, interaction. It's so cool. It has momentum. I mean, it has the energy mass, of course, but with mass I mean the heavy mass. Do you say it in English like that? So yeah, I mean photons are, yeah. So that's interesting. Yeah. But I did not understand the graphic. How would it work if it had a mirror? So the photons would hit the mirror would move. And the photons, oh no, they would be reflected back and they would hit the sun. So if all the photons hit the sun from one side, it would start to move. I see. So it's like they go into the mirror and they come back and they hit the sun. Yeah. But would that... Yeah, it would. I think it would work. It would work.
Than a flashlight because the sun produces a lot of photons. The basic idea of the Shkadov thruster is to reflect up to half of the solar radiation to create thrust and slowly push the sun where we want it to go.
But why would it go in that direction? Wouldn't the mirror move away from the sun? I'm probably being incredibly stupid here, and I'm sorry. Because the photons hit the mirror, and then the mirror gets pushed to that side, but it reflects them, so it gets pushed even more because you have to conserve momentum. Yeah, but it's probably working.
In order for the Shkadov thruster to work, it must be kept in the same place, not orbiting the sun. Although the sun's gravity will try to pull it in, it would be supported by radiation pressure, which props the mirror up. This means the mirror would have to be very light, made of micron-thin reflecting foil.
Yeah, okay, I get that. But so you would have to make it exactly as... Not exactly, you can have some leeway, but about as heavy as the photons hitting it and reflecting back. So the gravity will pull it back, so it's falling into the sun, so to speak, but it's also being pressed away and the sun is pressed away from it. That's cool. That's really cool. That works, I think. Like yeah. So that works. Yeah, I did not consider gravity because I'm an idiot.
Enveloping the sun in a giant spherical shell wouldn't work because that would refocus light back to the sun, heating it up and creating all sorts of unpleasant problems. Instead, we use a parabola, which sends most of the
like it turning into a hotter class and more energy dense star, or yeah, you might even turn our sun into a black hole, I think. Might be wrong here though.
Photons around the sun and in the same direction, which maximizes thrust. To prevent accidentally burning or freezing Earth with too much or too little sunlight, the only safe place to build a Shkadov thruster is over the sun's poles. This means we can only move the sun vertically in the plane of the solar system and one direction in the Milky Way, which limits our travel options a bit.
Yes, 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 and then you have to accelerate not too quick, which it would not do. So I now see how in this version I see how it works with the acceleration I talked about. I think it's not a quick acceleration, it just accelerates slowly. I think that would work. It might work. Yeah, it might work.
But that is
Great
basically
idea. Great idea.
For
Very
a
fun idea.
civilization
Great
capable
idea.
of building a Dyson sphere, this is a relatively simple endeavor.
It is. Because it's half a Dyson sphere and you only have to put reflective surface on it and don't have to build energy collecting like solar, let's call them sci-fi solar panels onto it.
Not complicated, just very hard to build. At full throttle, the solar system could probably be moved by about 100 light years over 230 million years. Over a few billion years, it gives us near complete control over the sun's orbit in the galaxy. But in the short term, this might not be fast enough to dodge a deadly supernova.
That's
That's
true.
why we thought we could do better. So we asked our astrophysicist friend if he could design a faster stellar engine for this video. He did, and wrote a paper about it that's been published in a peer-reviewed journal.
Yeah, you told me
You can
about
find
this.
it in our sources document. We're going to call our new stellar engine the Kaplan thruster. It works a lot like a traditional rocket.
Yeah, I read that up. So they have this, they have a professor who gives them advice and who checks this, and you feel it. This is checked by an expert. It's so great. That's why these videos are incredible. In Germany, no one checks any video we put out for education. So they are all shite in, I'm sorry for the word, they're all shite in content. They're flashy and you don't learn anything. And you mostly learn the wrong stuff because the people who do the videos have not understood them either. So sorry for that.
Shoot exhaust one way to push yourself the other. It's a large space station platform powered by a Dyson sphere that gathers matter from the sun to power nuclear fusion. It shoots out a very fast jet of particles at nearly 1% the speed of light out of the solar system. A second jet pushes the sun along like a tugboat. The Kaplan thruster
cool.
requires a lot of fuel, millions of tons per second. To gather this fuel,
You take solar winds.
our thruster uses very large electromagnetic fields to funnel hydrogen and helium from the solar wind into the engine.
Yeah. Great stuff, mate.
The solar wind alone doesn't provide enough fuel though, and that's where the Dyson sphere comes in. Using its power, sunlight can be refocused to the surface of the sun. This heats small regions to extreme temperatures, lifting billions of tons of mass off the sun.
Yeah, and that's what I said about the Dyson sphere. You can use so this type of civilization that can create a Dyson sphere, it has the power or the ability to control the sun, and that's why they can do that.
This
So this
mass
is
can
an
be
abstract,
collected and separated into
yeah.
hydrogen and helium. The helium is burned explosively in thermonuclear fusion reactors. A jet of radioactive oxygen at a temperature of nearly 1 billion degrees is expelled and becomes our primary source of propulsion from our stellar engine. To prevent the engine from just crashing into the sun, it needs to balance itself.
Yep.
To do this, we accelerate the collected hydrogen with electromagnetic fields using particle accelerators and shoot a jet back at the sun. This balances the thruster and transfers the thrust of our engine back to the sun. In as little as 1 million years, this engine can move the sun by 50 light years.
That's
more
great.
than enough to dodge a supernova. At full throttle, the solar system can be completely redirected in its galactic orbit in 10 million years. But wait, won't we use up the sun this way? Fortunately, the sun is so massive that even billions of tons of material will barely scratch the surface.
And something as well, you could focus the hydrogen back into the solar core, which again fuels it.
In fact, This megastructure will actually extend our sun's life, since lower mass stars burn slower, keeping the solar system inhabitable for many more billions of years. With a Kaplan thruster, we could turn the entire solar system into our spaceship. For example, by orbiting backwards in the galaxy and colonizing hundreds or thousands of stars as we pass by them. It may even be possible to escape the galaxy entirely.
It looks so stupid. Let's take the solar system going. That's great. That's such a great idea. And it's a sci-fi idea, but I don't mean that it defies our physics. It complies with every physics I know. I love that idea. It's just the details that we don't know. You know, that's what I mean. It's such a great idea. That should be used in a movie.
And expand beyond the Milky Way. Stellar engines are the kind of machines built by civilizations thinking not in terms of years or decades, but eons. Since we know that our sun will die one day, a stellar engine could allow the far future descendants of humans to travel to other stars without ever having to venture into the terrifying dark abyss of interstellar space. Until we build a stellar engine, we're adrift and subject to the whims of the galactic sea. We may not like where it leads us. Maybe our descendants will set sail and become an interstellar species for millions of years to come.
Yeah, that's what I said. That wasn't a rogue black hole though. But it wasn't one you could not detect because you saw the shimmer, the aura around the accretion disk. It's the accretion disk I talked about. This you see it twice. You see the back from top and bottom because of gravity lensing. Yeah.
This was our last video for the year 12,019 of the human era. And what a year it was. So much stuff happened everywhere.
Yeah, so that's it for today. At least for this video. Great video. Great video. Great video. So, yeah, might work. Might work. The only thing, as I said, I mean, I'm just repeating myself. I'm sorry. It's just the acceleration should not be instantaneous. That would be not good. But instantaneous. See, I'm getting tired. Shouldn't be too quick. So the acceleration shouldn't be too high. It should be an okay acceleration. Then it could work. That's such a great idea, and we won't have to get swallowed by this thing. So, yeah. If you like this, consider liking, subscribing. I will do more of these. Perhaps once a week I will try that. And I might make that work if nothing big comes up again, like the Dune movie release. And yeah, hope to see you soon. Have a happy day. See you around. Bye.